The next in our lineup of find series is known as the alternating series. When we say alternating, we mean going from a positive to a negative, to a positive to a negative, to a positive to a negative. These are the four most common examples, and quite frankly, the only four I can think of. But essentially, every time you have some sort of sequence, if I have -1 to the nth power, every time n changes, when n is an even number, this would be a positive one. When n is an odd term, it's a -1. And there's infinite variations of that where you just put this to the n +1 and -2 and plus 13 and a half. I don't know. Maybe not 13 and a half, but 13. Look, you can add any number you want to that, but essentially it means whenever this exponent's even, this is a positive one, and when it's odd, it's a -1. Therefore, each successive term changes from positive to negative. Same thing for cosine and sine here, though, because we know that when you go from cosine of 0 pi, that's 1, cosine of 1 pi is -1, 2 pi is +1, 3 pi, 4 pi. Whenever you change cosine by amounts of pi, it switches from positive to -1. Likewise, over here, that 2n minus 1 is just a fancy way of saying odd multiples of pi over 2. Any odd multiple of pi over 2. And once again, as you plug in different values of n, that will change from positive to negative. And there's only two rules for dealing with these series. So let me explain these two rules here, and both of them have to apply. 1 and 2, both have to be true if this series converges, if it converges to a number. If either one of them is false or if both are false, it's going to diverge. And it's real simple. If you take a look at the sequence, not the alternating part, but the actual sequence itself, if the limit of that sequence approaches 0, that's a good sign. And then if you can say every successive number, every time you go to the next term in the sequence, does, not the alternating part of it, not the negative and positive, negative, positive part, but just the sequence itself, does it always get smaller? Each successive term is smaller. Let's look at a bunch of examples. So now here's some examples to follow. If we take a look at these, what you need to do in each and every one, notice that, hey, there's something here. The -1 to the n, the cosine, -1. Ooh, it doesn't look like anything there, but it really is. They're alternating. So the first step for you to do is to figure out, well, gosh, what is that function that I'm really looking at here? What is that sequence that I'm trying to add up? And even though if we ignore the -1 part, the part that alternates, we basically have 1 over 3, 1/3 to the n. Now, as far as I can tell, that meets the first condition. It will actually get smaller and smaller and smaller. By the way, folks, that is that's right, a geometric sequence. And because that's less than 1, it will approach 0. So the first thing is checked. Second, will each successive term, every time n goes up by 1, will this keep getting smaller? Each successive term gets smaller. There we go. It meets both conditions. It converges. So take a second and look at B, C, and D and figure out exactly what would the original sequence be. If these are the sequences that you came up with, congratulations, you deserve a cookie. So you look at this and you're like, okay, the cosine, that was just the part that goes negative, positive, -1, positive 1. It just alternates between the two. But this one does get smaller every single term. Excuse me, that's number 2. Number 1, it will approach 0. Therefore, it converges. Number 3, likewise, if you look at it, it will start to approach 0, and each value does get smaller. Therefore, it will also converge. And then finally, for the last one, we look at that, and as it gets moving along, will it approach 0? Will that sequence, as n approaches infinity? No, it doesn't work. I don't even have to look at the next priority. And by the way, if I did look at that, each successive term would get bigger. So that one's going to diverge. But wait, there's one more thing. And I don't think this is on the AP exam, but it's good to know. There's something about converging conditionally or absolutely. It's conditional if it only converges for